Hey guys, today I'm going to show you how to accumulate good coverage between two executables sharing on the same code. So I'm referring to this contrived example here. We have main one. This will be our first executable. We have main two for the second executable. And then they have to share a common code here, add noun function. So first, let's look at the make file. So here is the make file for that. They share a common code, addnum.cpp. So this is a very small example to drive the point. Okay. So first, let's take a look at the first executable. It calls into the addnum function, passing 3, 4. And let's go to the second executable source code. It calls to the addnum function, passing 3, 3. And the common code looks like this. The addnum is very simple, but you get the point. If in the first call, 3, 4, it will hit this line here. And in this call where parameters are equal, it will hit this line here. And together, when the two coverage, the two executables are joined or merged, they should produce 100% coverage of this code. So take note that the constraints here is that the the common code, the path to the common code should be the same. Okay, they should be the same. I mean, in the absolute path, because even if the functions are the same, the content but the path is different, it will no longer work. So common code should have a common path. So let us begin, and I will be using Parasoft tool here. So first, I will create the BDF of the first code. So I will run cpp test trace cpp test trace output file. Then it will be the app1 BDF make there. We generated the BDF of the first project. Let us take a look at the BDF. It lists the sources of the BDF. It lists the source of the main app and the common code. You will also notice that it compiles the executable. So this is how Parasoft generated the BDF. It compiles the your code, okay, as is, but through the process of compilation, it knew what are the source files that are comprising the application. So it intercepted the compile process via the cpp distrace utility, which is a Parasoft utility. This will serve as the parent process, and the child process spawned from this via the make command becomes children of this executable, and they are parsed. They are parsed, and that is how the BDF is generated through this parent-child hierarchy. Now let us generate the BDF of the second application. It will be up to that BDF, and then I will specify up to here as a target. And now we have both application app1 and app2, and we have two BDF. Likewise, I will print the content of app2, and it is listing the source of application 2. Now that we have two BDF, and it could be a very big application, I am making this very small to drive direct to the point. Okay, now that we have two BDF, I will launch the Parasoft IDE, which is an Eclipse-based IDE. And Eclipse-based uses the concept of workspace. So I will create a workspace in this location. This is where I put my workspaces for the app one. And we will associate this workspace, app one workspace, to the app one project by loading the app one BDF. Okay, first let me first let me increase the preference console to high verbosity. This is just preference of mine. And then now, by default, this is BDF is still not this workspace has still no project in it. So we need to load the BDF of app one, browse button and SRC, and here's the app one PDF. Okay, yes, and double check that your compiler family is detected. I am using GCC 13 here, and it auto detected and correctly set to GCC 13 compiler family. Compiler family is not the compiler. It is a compiler family. If it is not auto detected, either you will click auto detect button or you will drop down and select from among the supported list of compiler family offered by Parasoft. As you can see, there support the Parasoft C++ test supports Clang, GCC, ARM, and other proprietary compilers like TI, etc., and many others. So now, after setting the compiler family and these fields are populated correctly, okay, GCC for compiler, G++ for C++, and then G++ for the linker. Click finished. Now let's open the main. Probably let's go to the add function. Now that we set here, I will um, customize a Parasoft test configuration. And the test configuration that I will use here is that particular configuration that directly runs your application without needing any test cases being generated. You heard me right. Like just your application, take it as it is, your application, instrument that, and then gather code coverage from that. Okay. So that particular configuration is this one. The application monitoring, and I'm referring to this one, build and run application with coverage monitoring. So this configuration, particular test configuration, does not require you to generate test cases, does not need your app to have any test cases. Just your application is compiled and instrumented, and when that application is executed, code coverage will be gathered. So since the built-in configuration are read-only and there's no way to modify this, we need to duplicate this first. And once it is under user defined, and let me first rename this to avoid confusion, just put my, and once it is now under user defined, go to execution tab. Okay. And under execution tab, select the runtime tab under it. And then right down here, there is this archive test and coverage results. Check that checkbox. So there. And then, so since these are two executables, right? And potentially different different paths for these executables. But again, I have to repeat, the path to the common code should be the same. Okay. Now, every test run will gather code coverage and they need to be written into a common folder so that this path is visible by the two applications. So I will click browse and I will select SRC. I already created those two folders in the archive. Okay, there. And this will be the same path that we will set when we configure the second application. Done. Now we will compile your application. We will instrument and compile and run your application using this configuration. So click here, right click, and select your user-defined application monitoring, my build and run application with coverage monitoring. There. So if we go to main, you will see that the main app passes 3 and 4. So that explains that the code coverage that we are seeing here. Okay, now I will exit this IDE, and then we will see in the archive folder, these are the coverage log that was gathered from that run. Okay, so these are the complete files. Now it's time for the second executable. So I will launch again the IDE. Since these are two separate executables, so two separate workspaces are needed. Then I will put app2. And again, the same process as done in the first application. Let me set the preferences to use high verbosity console log, and then I will associate this workspace to the second project by loading the BDF of the second project app2.pdf. And the second project is now loaded. Let's take a look at the main. So the main here calls to the add num function passing 33. Like before, I will create a customized application monitoring for this workspace. And then go through exactly the same process, enable this archive test and coverage results, and then point it to the same location here. Okay, so apply. Okay, now let us run this. Let us run an instrumented build that's using user-defined application monitoring, my build and run application with coverage monitoring. There, and it will be the coverage report of this one is slightly different from the first one. Now, this is the final moment of truth. Since let's go check to what's written in the coverage. So now in the first run, we have only this match file. In the second run, we have more files here. These are the combined coverage of the two execution runs. So we can do it here in the second IDE or in the first IDE in the first project, but I will do it here. So first, I will need to customize a final test configuration, which is the load archive results. And then here, I will edit the location of the log files. So I'll edit here. That will be home tx src 2xs archive. And as well as the location of the map files. which are in the two axes. So let's review. So you can see the map files are in the two axes subfolder. Close. Now I will generate a report from this merge coverage data. So right click, utilities, my load archive results. Now we can see the two covers have been combined. And if we take a look to here, the add num function is 100%. And we can generate a report. And we get 100% of the add num function resulting from the combined coverage of the two execution runs. Thank you.